The Cetacean Acoustic Trend Tracking Project, CATT, uses Chelonia F-Pod passive acoustic monitoring devices to track dolphin and porpoise population and distribution trends around the UK coastline. Picking up again from where we left off, investigating the data in the files, we were on the Fowey file. But we change so many things in there quite often it's well worth shutting the whole application down and starting it up so you know you're back on defaults. Now I often, because I change in the last one, I changed the skip to 512 and I changed so the filters in here, the clicks per second. You can clear all these in each section or all of them, but the skip to you have to change manually, and some other things too can easily catch you out. So I tend to frequently restart the whole application. I also changed the FP1 to 2, so I'm going to leave it everything on defaults again now. So we start off with just a default set of data. I'm going to reopen the same file we were looking at, which is the Fowey JBoy. And this time we're going to do a bit more graphing. So I'm going to just look at NBHF and other cetaceans, fit the whole time range on the screen and show from start, and then we'll load the whole file and get an idea of what sort of detections we've got in there. I seem to remember this was quite a good file. There we go. So there's quite a few dolphins there, fewer porpoises. See a tidal pattern coming out in the raw data there. But there's plenty to work with. So this is quite a nice file. It's not a very long one either, so it loads and processes fairly quickly. So in a previous video, we did play with graphing a bit, and we did go into the display tab and change some of the settings. We're going to explore that a bit further this time with this file and some other files and start looking for some of the differences we might see. So initially, I'm just going to have a look at narrowband high frequency and just graph that, and it will come up with a default set of graphs. So at the bottom of the screen we'll see the frequency bandwidth in the FP1, and then in the other three we'll see some numbers from the FP3, from the output of the train detection algorithm. With NBHF, narrowband high frequency, we would expect the frequency range for those detections to be a narrow band centered around 120 kilohertz, which very quickly get used to spotting in the F-Pod software, because it comes out with a color coding of a nice violet color, which very quickly becomes associated with porpoises as you look at this data. So there we are at 190 million clicks, a lot of low frequency noise, predominantly low frequency. This deployment was hanging from a racing mark of Polruan. So it's less likely to be sediment transportation here. This is much more likely to be surface noise and bubbles and waves breaking, and maybe some chain noise from the buoy as well. The detections, narrowband high frequency, as we would expect, have only about 29,000 clicks in there. A nice wide range of frequencies there, so lots of activity across a whole lot of click rates. And certainly a preference for the evening, certainly up to midnight, and in quiet periods through the mornings. We'll compare that to the other cetaceans, which will be our dolphins, and I'll just graph that for cetaceans, and we'll see how that looks. So the bottom graph will be the P1 raw data, so that will be exactly the same. The FP3 will show us just the dolphin graphing. In many places around the southwest in particular, the diel pattern is quite an interesting one. We are seeing a definite preference for clicking in the hours of darkness overnight, much less during the day. We can't say whether that means they're just clicking less or whether they're moved away somewhere else, but there's definite pattern there, yeah, and it's come out in this one too. They start clicking more than average about 8 o'clock, and consistently clicking more than average up until about 4 o'clock in the morning, where it gets much quieter. Again, quite a wide range of click rates there, and a wide bandwidth of frequencies. a lot more, 216, 217,000 clicks, so more porpoise activity. I mentioned before that in the display tab you can look at other things in here. So drop down one of these, there are a lot of different things that you can graph on there. I won't go through all of these now because many of them are quite advanced. Having seen what a default graphing session looks like with a standard file set, I'm now going to move on and do something slightly different by closing that and opening up to 6 unrelated files. That's because I want to open some FP3s without FP1s. Now let me remember where I put these. I think they're in my workshop folder. And down here, when you click that 6 unrelated files, you can choose to filter out. So I want the FP3 files, so I choose that one there, and that will filter out all the other ones. And I want these 3 here. So these are from Wales. CB is for Cardigan Bay, and there's one from Skomer. So I'm going to pick those 3 up there and open them. And I need to change these because they are FP3s. I'm particularly interested in species. And when I set the bottom one, I can set all to match. So I just click on there. Let me quickly check. I haven't set any filters in there. If I just clear all blue filters, I'm going to be absolutely sure. I want to look at NBHF and other citation. I will include low as well for the first look. Fit hold time range on screen and show from start. So there we go, no FP1s, just 3 views of cetacean detections from 3 different sites over the same time scale. You see there's a bit of a gap there, that file actually stopped. So there is another file which goes to the end. Already we can see as I hover over each bar, you can see the name comes up at the top. So the top one there is Skomer. That was in St Bride's Bay, just down near St David's Head. Cardigan Bay 6 was an offshore site, so this is quite a long way out to Cardigan Bay, where Sarah Perry, who works there, tells me that you're more likely to get Bottle Nose Dolphins in the offshore site, as opposed to the inshore site here, CB4, where if there are dolphins, they're more likely to be common dolphins, but as we can see from all the purple detections there, a lot more porpoises than dolphins inshore, a lot more dolphins than porpoises offshore. Bit more even, but more dolphins than porpoises at Skomer as well. I'm going to do a similar thing now with the graphing because we have 3 FP3s. What I really want to do is see the kilohertz in all of them. So I click set all to the same type, and we're going to look at kilohertz there, and we're on NBHF. And if I graph that, that will show us pretty much what we expect. Narrowband high frequency centered around 120 kilohertz. Quite different numbers there. The 2.5 million in that inshore Cardigan Bay site where we saw a lot of porpoise activity. 768,000 in the offshore and 878 around Skomer. Pretty much as we would expect there. They're quite long files, 159, 126, 165 days. This is averaged over that whole period, so this is very habitual behaviour and very distinctive. You see some similarities there. There is a little peak there at 124, another one there at 124, another one there at 129, slightly different. These subtle little characteristics are quite interesting to see if they're repeated on the same site through the year and if those little characteristics move as the pods move around. Now, one of the reasons I picked these 3 is because there was a very surprising result when I did this for other cetaceans. So we'll do that now. Now, as you know, when we do other cetaceans, we normally see a very wide band of frequencies. And we certainly see that on the inshore Cardigan Bay site here. A lot of low frequencies down around 15 to 20 and frequencies going right up to 140 here. Likewise at Skomer, a big peak around 42 there, but going down to much lower and another big peak that we often get around 21. This one was a big surprise, Cardigan Bay offshore. Now there's this site where we're more likely to get bottlenose dolphins than anything else. Say in the data I've looked at around the UK, I've never seen a dolphin frequency bandwidth looking quite like that before. Very narrow, centered around 42 kilohertz. So very unusual. We're quite excited to see what the next one is like if that pattern is repeated. As we just showed when we looked at the NBHF, we know the pod's working. It was picking up the porpoises perfectly well at 120 kilohertz. So there's nothing wrong with the pod there. It is working on a full bandwidth of frequencies. It just appears that these dolphins are habitually clicking in that very narrow band frequencies there, which is very surprising. Given something like that, what I might do then is have a closer look at that file, see if I can see what's happening there. So that's the Wales Cardigan Bay 6B. So what I might do is close that down, restart it, and just with a default set, open up that Cardigan Bay 6B and have a look at that in isolation. Yeah, I've got 3 FP3s there. So I think I'll look at frequency. I'll look at species class, I'll look at clicks per second, and I'm just interested in the other cetaceans. So let's see what that gives me on the screen there. Okay, so I can see there are a lot of dolphin detections there. But the frequency here is nearly all that orange color, which represents the 42 kilohertz. Normally here we see a wide range from red at 20 kilohertz all the way up to the violet around 130, possibly even 140 kilohertz. But already that's showing me that all those click trains that we've detected are predominantly around that 42 kilohertz. So again, what I'm going to do, like I did before, I'm going to put this up a bit so I see the longer click trains. Put this down to about 20 milliseconds, show from the start, and we'll start looking at some of these click trains that we'll see in the top window here. So I'm going to bring that into view here. So I can see that's quite high rate there. There's some these look like navigation, low click rates, possibly some social communication, little buzzes here. But again, these frequencies, I'm not filtering anything at all here. This is everything the pod heard. But those frequencies, those orange colours and yellow colours, very, very narrow in the band of frequencies. So we'll click through the file and see if we can see a range of different click trains. We're seeing some navigation, some up sweeps, down sweeps. So that's possibly some feeding activity there. But again, all the frequencies pinned around that 42 kilohertz. Okay, so lots of navigation all happening at that lower frequency. And there's some more feeding activity possibly there. Let me zoom in on that a little bit and see what we can see there. So that's going up fairly high there. So a strange little call. That's going up, that's a little feeding buzz there. But again, the frequencies, you can see the individual clicks in that click train. There, every single one is just that fixed frequency. So we'll move on a bit more through here. There's lots more various activity, very, very consistent in the frequency. The amplitude is changing. The number of cycles is changing. That's the height of each line. So if it goes up to there, that's 12 cycles. Down here, that will be 1 or 2 cycles. So we're looking at some very long clicks there, going up to 30 cycles. Amplitude varying quite a lot, but always that frequency. That really is quite remarkable. I'm going to bring that down again because I put that right up. So I'm going to start maybe looking for some slightly different things. So I'm going to filter out the clicks maybe below 50 and start looking at some of the stranger activity. So that could be social, possibly. Click rates going up to 360, up to 20 cycles a second, all the way down to 2 cycles. So not very loud, very quiet. Might be a bit distant there. Let's pull that up a bit. So let's actually, what we can do, let's just play that back. That's a good indication that those changes in pitches are reflecting the changing click rate. The frequencies there are all pretty much the same. And if I graph that, you'll see the frequency range in there is absolutely pinned around that 42 kilohertz. But when we play it back, we hear the changing click rate. It's quite a nice little sequence there. Let's come out a bit and have another look. Quite a bit of activity in these screens. Some feeding, some socializing, and some big calls there. Let me pull that back, look in there a bit. So that's really nice, isn't it? So that orange, all the same. Let me play that for you. Very strange. Let's see if I can zoom in on that a bit. They're quite unusual calls here. They may be feeding, foraging, social communication. This is all the things that are being studied at Chelonia at the moment. A lot of what I do is try and gather data and push it at the PhD students and ask them the question, what on earth is happening here? Because it really is quite surprising sometimes. That's an interesting one. Sometimes I do see, if we look at the clicks here, there's a short period in there. There may be a harmonic there, so that picked up some much higher frequencies in there. If I graph that, there you can see there'll be harmonics maybe, just those higher frequencies bouncing around in there. But I've seen a few like that. Suddenly, in the middle, you'll get some much higher frequencies shown in screen. We're seeing all sorts. There's a nice feeding bus, but all the frequencies of all these clicks in all these click trains are pinned around 42 kilohertz. We can see there are some low click rate navigation calls. There are some feeding buzzes going into several hundred clicks per second. Various social activity, up sweeps, down sweeps, some repetition, but all around that same frequency. Really is fascinating. Looks like more feeding activity possibly there. So absolutely fascinating stuff in there. I'm not at all sure what to make of that or how we could interpret it. Let me come out. Let me see. There were NBHF animals in there as well, weren't there? So show from the start. Have a look through with all the same settings. All I've done is switch off other stations, switch on NBHF, and we'll click through here. So here we're seeing some porpoise activity. We can already see the frequencies here are 120 kilohertz. The click rates, I've got that set quite high. That's going up to a few hundred there. Let me stretch that up. Show next screen. I click through a few of these. There's a lot less porpoise activity. There's a nice big feeding buzz there. Let me bring that down a bit. Have a look at those individual clicks. There's one unusually loud one in there, but the software has smoothed it out to give us a nice consistent click train. This shows that the pod was working properly and picking up lots of other frequencies as well. It wasn't just picking up that narrow band around 42 kilohertz. There were lots of other things. There's a nice little sequence in there, that possibly some feeding activity, lots of up sweeps. These sharp edges I've mentioned a couple of times. Probably is a long continuous click train there over several seconds, but as the animal is sweeping it around, we get these sharp edges showing that it just flipped away from the pod, came back to the pod and flipped away. So we get these sharp edges, whereas before I was pointing out some of what do we think might be social activity. Where we get a whole click train, we see it ramp up slowly, peak, and then ramp down slowly again, suggesting that we've got a whole click train. That's one of the things that we look for. Nice feeding there. Let's move on a bit. There's a lot less porpoise activity, and where we see these encounters, there isn't a lot happening there. So there may be, I would guess, maybe small numbers of animals in this pod moving around. There's a That's hard to say whether that may be repetition rather than a continuous click train that is just broken up by the beam swinging around. They all start around the same click rate and they all end around the same click rate. Very similar pattern to it there. This sort of repetition is another thing that may suggest some social activity. That's something I like to look for. Let me zoom out again and just keep moving through this. So we can see from the white marker here we're only maybe a fifth of the way through this file. So although these aren't big encounters, there are quite a lot of them. And there's some quite nice shapes there. That's bring that down a bit. It's getting quite loud. They were probably quite close. These white marks here, I've mentioned them before, I'm sure. They mark, so these individual clicks here, let me zoom right in on that. So within that click train, we can see the individual clicks. In the raw data here, we can see the individual clicks, and these are the ones that the train detection algorithm is working with. And it marks where the loudest cycle in each click is. So each one of those lines is a single click. And that click was a waveform with 16 cycles in it, and the loudest cycle was maybe 5 cycles in. It's one of the clever things the software does to work out which is the next click in that click train. It looks backwards and forwards and at several of the features, I say several, about 70 or 80 features of each click to decide which is the next click in the click train. And we can't see it here with dolphins in particular. We get a lot of reflections and refractions and multipath propagation. There's lots of extra noise, and the software in real time has to work out which click belongs in that click train and which one can I leave out. And even if it leaves something out, we can still look in the raw data and see for ourselves what the algorithm decided to do. It's quite interesting to see what the algorithm chooses and what it doesn't, but surprisingly accurate. So moving on. Yep, a whole range of high click rates, low click rates. We're filtering a lot of the lower ones out at the moment. I must remember that I've got filters in. Getting into a slightly bigger sequence there. So when I got these filters in, if I hit F4, it will sometimes show me there's a few extra things in there that we're filtering out at lower click rates. And there's some unclassified clicks here at much lower frequencies. It is that F4 is a useful one for seeing what else is happening around there. That's quite a nice little range of calls there. If I hit F4, there's not much else happening around there. That is quite nice. Let me play that back. Any guesses as to what they were saying there? Okay, let's keep going. We're still only about a quarter of the way through the file. I often do this for a long time. It's an interesting sequence there. And every click you see something that surprises you, something slightly different. And there's a nice long call. And it's interesting to see how the amplitude varies with the click rate. What I often see in a feeding buzz, at the beginning of the feeding buzz where the click rate is low, the amplitude will be higher because the animal is looking further away and those clicks have to travel much further. As it closes in on the prey and the click rate increases because the return time of the click through the water is less and less, it will actually decrease the amplitude quite a lot. They don't have to be so loud because they've got far less distance to travel. With social communication, there is quite often a strange undulation in the sound pressure level, in the amplitude. Sometimes you can liken that to the head bobbing up and down in time with the tail beats as the animal is moving. Other times it seems to be too fast for that, and this is a fairly long call, so this may be some head movement that we're seeing there as the animal's moving. We can only guess at what might be happening. Showing. There we go. I'm going to switch back to other stations, show next screen, and again we've gone from that purple right back to this orange. Everything in here now is going to be that. That's quite a nice one. A big, that's over 700 clicks per second. Me F for that. And there's a lot more happening around there. A lot of navigation, possibly at much lower click rates. Even though all these frequencies here do look very similar, but that does look to have some additional frequencies in it. So let's have a graph that. There's a few extra frequencies in there. So that's quite interesting. It shows these animals can click at other frequencies when they want to. It just seems that they choose that 42 kilohertz and pick out some of those higher frequencies. So even when I zoom right in like that, I can still graph it. I can see when you zoom right in, there's definitely the pod was picking up dolphin clicks in a range of frequencies. These are quite loud, but they don't look loud enough. We're not getting multipath propagation here. That would be the case where there'd be a loud click, and then there'd be lots of small clicks here, which are all the reflections and refractions coming back. Sometimes you get alternating clicks, like you'll get a loud one at a higher frequency, and then maybe a much quieter one at a lower frequency, and then the software can see which ones are reflections and refractions and which ones aren't. But I can see nothing in here that would suggest why these animals are clicking at that rate. It doesn't seem to be anything technical. It definitely is happening. It is a real effect. So we are very interested to look into that and see what else might be happening. So yeah, when we get another file, maybe I'll do a video and compare them, and we'll see if that is continuing, or if we can narrow down any reasons as to why that might be. But okay, we'll leave that one there for now. Thank you. All of the data gathered on the CATT project is open source at the Figshare Plus open repository in the project called CATT. The software we use to analyse the data is available at the chelonia.co.uk website called fpod.exe. ARDA UK was established to set up the CATT project on behalf of Chelonia.